This will be the third video for your Unit 14 pre-cal review over logarithms for the Unit 14 test. So 16 here, we're picking up there. Solve 5 raised to the x minus 3 power equals 25 raised to the 4x plus 1 power. So whenever we're solving these exponential equations, and again it's an exponential equation because we have variables in the exponent location. When we're doing that, we have two choices. We can either set like bases, if that's possible, and solve, or we need to take the logarithm of both sides. In this case, I can make that base right there 5 squared. So I can set like bases here, so that's what I'm going to do. So 5 squared, same thing as 25, still raised to the 4x plus 1 power. Then we apply our outside to inside exponent rule here, and just remember that you're multiplying that 2 here by both the 4x and the 1. So that would give you 8x plus 2. And now we have like bases, so we're allowed to set their exponents equal to one another and solve. So x minus 3 equals 8x plus 2. So we can subtract, actually let's do this, we'll subtract 8x here, subtract 8x here, that gives us negative 7x, subtract 3 equals 2. We'll add this 3, add the 3 there, and we get, coming up here, negative 7x equals 5, divide by negative 7, and we're done. X equals negative 5 over 7. So that would be the answer to number 16. Let's look at 17. Alright, problem 17 here, solve log base 5 of x squared plus 9 equals 2. So the easiest thing to do here is use the loop rule and convert this into an exponential and work to solve it. So we get 5 squared equals x squared plus 9 using the loop rule. So we get 25 equals x squared plus 9. And we can either work through it and solve it by factoring or through the quadratic formula, or we can use square roots and do that, and this is going to be the case here. So 25 minus 9 is 16 equals x squared. So you can see here that we have a number 16 here that has a perfect square root, so we can just take the square root of both sides. When I do that, I must put in that plus or minus sign there. So the square root of 16 is 4, so the answer is plus or minus 4. So x equals plus or minus 4. We have two answers, positive 4 and negative 4 on that one. Just remember, when you introduce an even root, when you're solving, you must include that plus or minus in front of the root. Alright, let's move on to 18. Alright, problem 18 here. We're solving a logarithmic equation. So we have ln of x minus 7 plus ln of x is equal to ln of 8. So we're solving for x here. And first thing we're going to do is combine these two logarithms into a single logarithm by condensing them using this theorem here. So the addition that we have now will combine the arguments together through multiplication here into a single logarithm. So ln of x times x minus 7 equals ln of 8. So all I did is I combined this argument with this argument through multiplication. So we'll distribute here and here, and we get ln of the quantity x squared minus 7x. That's the argument of that logarithm equals ln of 8. So now I have it set up so I have one logarithm set equal to another. Therefore, the arguments must be equal, so I can take the x squared minus 7x and set it equal to 8. We can drop the logarithm once we do that. So x squared minus 7x equals 8. We'll set that thing equal to 0. So minus 8 equals 0. And then we can either factor or quadratic formula. This one will factor. It will factor to x minus 8 and x plus 1 equals 0. We multiply to negative 8 there, and we'll add negative 8 plus 1 is negative 7, so we know that factors correctly. So that means the possible solutions are x equals 8 from this factor and x equals negative 1 from this factor. Now we have to go back and check and see if either one of these solutions would cause us to take the logarithm of a negative number. And if we plug in negative 1 right there, or even here, we would be taking the logarithm of a negative number in that case. So we actually have to reject this solution, and we only keep this one. So the only answer to this problem is x equals 8. The negative 1 has to be rejected. Okay, problem 19 here, solve log base 2 of x squared plus 7 equals 4. So in this format, it's usually beneficial to use the loop rule and convert it into an exponential. So 2 to the 4th is equal to x squared plus 7. So 2 to the 4th is 16 equals x squared plus 7. We'll subtract this 7 here and see what we have. 16 minus 7 is 9 equals x squared. So I have a number that has a perfect square root, so I can just solve this through the square root method. So I'll square root this side, add the plus or minus here, and square root this side. Remember, you must include that plus or minus when you take the even root in solving. So that would be plus or minus 3 is equal to x, and we are done with that problem. So we have two solutions, positive 3 and negative 3. Now we do check that, we can. If you plug in a negative 3 there and square it, it flips it to a positive, so that one's okay. And of course, if you plug in the 3 there, you input the positive 3 there, of course it's positive, so it's fine. So both solutions are acceptable. Problem 20 is the next one and the last one. Alright, problem 20 here. Solve log base 6 of the absolute value of 2x minus 7 equals 2. So in this format, we're going to convert that into an exponential. So we get 6 squared is 36 equals the absolute value. Don't forget the absolute value part of the quantity 2x minus 7. So whenever you have these absolute value equations, that causes you to solve for positive 36, 2x minus 7, and negative 36 equals 2x minus 7. So we have two equations to solve. So if I add 7 here, I get 43 equals 2x, divide 2, and I get x equals 43 over 2 as a solution. That one is acceptable. It doesn't matter what value of x, positive or negative, I'll put in here, this absolute value will flip it to positive, and therefore I am taking the logarithm of a positive number no matter what. So that solution of 43 over 2 is acceptable. So add 7 over here, and I'll get negative 29 equals 2x, divide 2, and we get x equals negative 29 over 2, and that also is an acceptable answer, because if you plug that in and put that in for that x, it will give you a negative number inside here, but it will flip to positive because of the absolute value here. So it is also acceptable. So that's it for this video. That's it for your Unit 14 pre-cal review.